Okay, so now we're going to do an example of an application type problem again. And so I'm not going to write the whole thing out, but I want you to listen and take notes. Okay? So it says, suppose the growth rate, or excuse me, the growth rate of bacteria in a petri dish is given by Q of T, so quantity over time, if you will. So it's given by 3 to the T power. Okay, that's the growth rate. Where T is given in hours. And Q of T is given in thousands of bacteria. Now it says if a culture starts with 10,000 bacteria, so let's call this Q0. It says find the function capital Q of T that gives the number of bacteria in the petri dish at time t. And then it says find the number of bacteria after 2 hours. Okay, so it's a two-step problem. So the first thing is we need to find Q. We have to find the antiderivative, right? And then we can use that equation, that function, to find the number of bacteria after 2 hours. So let's do that. Okay, well, so this is the growth rate. Okay, so this is going to be the derivative of this. So this is the antiderivative of this. Okay? So this Q of T is going to equal the integral of QT. dt. Okay, that should make sense. So that means, let's do it this way. So that means that all we're going to do is substitute in 3t. So this is going to be the integral of 3 to the t power dt. Now the thing is we don't have to do u substitution here, because it's just 3 to the t. All we have to do is use the general rule of we're going to get the same exponential, but then we're going to divide by the natural log of the base. So Q of T equals 3 to the t divided by the natural log of 3. Okay. Well, plus c. So now, guess what? We're going to have to solve for the constant again. So we're going to use this information. Well, at t equals 0, we have 10,000 bacteria. So now let's solve for c. So that means 10,000 is going to go here, like so. And of course this is going to be 0 over the natural log of 3. Okay, which 3 to 0 is just going to be 1, so that's just going to be 1 over the natural log of 3. Let me do that. right? So this is just going to be 1, okay? And so what does C equal? Well, if we just solve for C, C is approximately, so you're just going to subtract both sides, and so you're going to get C is approximately equal to 9.090. 9.090. And so the function becomes Q of t equals 3 to the t over the natural log of 3 plus 9.090. And so now we've got the first answer. Now we can find the quantity of bacteria after 2 hours. Because t represents hours, so we're going to put 2 in for t. So then Q of 2 equals what? 9 over the natural log of 3 plus 9.09. And remember, this is in the thousands. So the answer we get for Q is 17.282, approximately. 17.282. So after 2 hours, there's going to be approximately 17,282 bacteria. And that's it. So now, here's one for you to work on. So let's say we have this situation. Let's say that instead we have Q of t is equal to 2 to the t, and we're going to assume that Q of 0 is 10,000. So we assume that the culture starts with 10,000 bacteria. So A, find Q of t, and then B, how many bacteria are in the petri dish after 3 hours. So in other words, Q of 3 equals what? Okay, so that's for you to work on. And again, if you have any questions or if you want confirmation of how you did, if you did it correctly, reach out to me. Have a good day.